In this section of the course, we're going to pull our knowledge together and look at some real-world architectures and best practices so you can turn your knowledge into solutions. So how do you plan and build on the Google Cloud? I often start with reference architectures, so I'm going to talk about some of those in this section, and I then generate iterative projects. One technique I've had particular success with that I want to call out and share with my audience is the use of lean startup techniques, which is a set of processes that come from the manufacturing world, and they result in something called an MVP, or a minimum viable product. I've had a good track record of success working with and using lean startup and MVP processes when implementing cloud practices. And I think the reason is that there's so much that's new to the teams when I'm working with the cloud that if we break off the solution into small chunks, small projects, we have a better opportunity to be successful with those small projects and to practice and learn. So the first reference architecture I'm going to discuss is probably the most common, which is deploying web apps on Google App Engine. And let's drill down and take a look at what this architecture entails. So you can see on the front end of the client, you've got browser, and then you've got various mobile applications. And Google shows Google Load Balancer, which is used to distribute the traffic. And then optionally, that's why this is grayed out, possible use of Google Cloud DNS if that is something that would be necessary for your solution. The core services here are App Engine. Now notice App Engine is your front-end app, and it has auto-scaling turned on, which is the default. And it's a reason to use App Engine as a platform or a managed service when hosting web apps is that you have spiky traffic or exponentially growing traffic, and you don't want to worry about manually partitioning and scaling. You want to rent or use a service on the cloud that will scale for you. So it's a real compelling reason. I've used this with startups in Southern California where they're doing social media kind of startups, and they're going to have events around launches of movies and other types of entertainment events, sports events, where they're going to have really spiky traffic and they don't know how large it's going to grow. And rather than having DevOps people to worry about that, they just worry about the functionality of their application. Now, it's common to use some sort of caching to make some aspects of your app render even more quickly. So Google has a Memcache. It also has some of the NoSQL in-memory databases like Redis, which you can use either as an IaaS, in other words, on Google Compute Engine, or you can use Click to Deploy from Google Compute Engine if you want a pre-configured setup for that. In addition to the front end, this architecture also references some cloud storage, which hosts some static content. And the reason you'd use this is because it's commodity priced and super cheap. So this goes to using multiple data stores. And you can see the dynamic content for this reference architecture is shown with Cloud SQL for the relational and the transactionally consistent data, and Cloud Data Store for the eventually consistent data that consists of entities. So this is a typical but new to many of my customers type of partitioned data architecture. So it's partitioned by service rather than partitioned within an implementation. So what do I mean by that? The partitioning is some data on cloud storage, which is a file system or blob store, some data in relational, Cloud SQL, and some data in Cloud Data Store. And this is opposed to more traditional architectures, which would be all data on a relational store that was then partitioned within the store. So it's a very new way of thinking about data, but it is one that is suited towards cloud scale applications. Now, in addition, you may have some worker task queues, and you may have an additional set of instances of App Engine for processing. So an example of this would be a social application where you had photos that the end users could upload, and you wanted to do some processing of photos, and you wanted to separate those processes from the rendering of the front end. Maybe you want to queue them up, and when the photo is ready, if it has process X, Y, and Z, then you want to store it in one of these scalable databases and then render it on the front end. So there's many different services and configurations, but the key aspects to this is splitting the processing from the rendering in App Engine instances, and then using this new architecture of partitioning data across different types of data solutions rather than within a data solution. The next cloud reference architecture that we're going to take a look at is one for mobile apps and games. Now, if we look at the core architecture, we can see that we have some similarities to the one that we just looked at in the previous movie for websites. The difference is this is designed primarily for mobile, And we're using some services that are specific to specific types of mobile. So for the iOS, we have Apple Push Notification Service. Notice we're using Google Cloud Messaging for communication to Android. Now, in addition to that, you see that we're using Memcache again for caching and task queues. The Google Cloud services are what we really want to focus on here. So something new we see is Cloud Endpoint. Do you remember from the movies about Google App Engine that Cloud Endpoints provide core infrastructure using App Engine instances without a front-end interface? So it's designed to work in conjunction with an App Engine interface. So what's an example of that? One common example is using Google's OAuth or authentication services via cloud endpoints so that the developers don't have to take the time to write custom authentication systems, which is quite time-consuming. There are other types of services that are available through endpoints, and also endpoints can host your service. So the idea with this is middle-level processing without front-end display. That's provided by App Engine. Even though it's kind of weirdly called mobile backend, this is the screen that you see on your mobile device. As with any other App Engine instance, it auto-scales so that if your mobile app becomes viral or has a huge spike in traffic, your developers do not have to worry about scaling or failure. The App Engine instances will automatically scale. In addition to this, we now have Compute Engine, which has a batch app rather than another set of App Engine instances for middle processing. And the reason you might choose to have Compute Engine is you might need to install custom libraries. You might want to do some type of processing that's restricted in the PaaS solution. This is a common point of decision in architectures. How much control do you need to have over the services that are running on the cloud? PaaS services like App Engine are having the advantage that they are auto-scaled and less for you to do in terms of maintenance and taking care of them. However, you have less ability to install custom components and do custom processes. Sometimes you have to go with IaaS or infrastructure as a service in instances like Compute Engine when you need, for example, to install custom libraries, do custom processes, so on and so forth. Here we also see the common pattern in the cloud of multiple data stores, so partitioning the data across services. So this is an architecture that I've actually worked with one addition. So here we've used Cloud Data Store because we want to have eventually consistent data. We're not really worried about transactionally consistent. We're very worried about latency. So an example of this would be some of these driver services. For example, an Uber or a Lyft type service where the customer is standing there. They really want to get that car ride and they want to see it immediately. They want to see who's available. And if one car is then driving someone else, then it'll just be replaced by the next nearest car. So the ability to be transactionally consistent is not as important as is speed. So Cloud Data Store is one of the options for storing data in that kind of situation. In this case, we use cloud storage for image storage, and the reason we do that is to save money. Again, cloud storage is your commodity storage. It's your file system, and it is exponentially cheaper than other types of data storage. So partitioning off data into cloud storage is a strategy for reducing costs, especially when you're going to be storing huge amounts of data. A new component in our architecture discussion in this particular architecture is BigQuery. And why we might use BigQuery in this case is if we are working with a gaming app, there might be behavioral data or other gamer data groups within our gamer that we need to get information about, ask questions of. And it could be a very large data set. It's quite common in social gaming to capture every activity that is performed in the application. So every touch on the screen, every piece of data that's entered. And this can result in a very, very large data set. So a data service like BigQuery allows these queries that are processing large and huge data sets to execute and get the needed results back within the appropriate amount of time. Again, mobile apps and games are all about lots of data and speed. So this is a very, very common architecture. Now, something I would add to this is there might be a need to use Bigtable rather than Cloud Data Store, depending on how the information was coming in. So from an architectural standpoint, what would make the decision between Cloud Data Store and Bigtable would be the structure of the data coming in. Bigtable is, as it sounds, works best with a huge, wide, flat table, whereas Cloud Data Store can work with nested data sets and can also allow for additional indexes. So it depends on the structure of the data and the type of queries. Another thing I want to mention, there's no discussion here about development, but one important aspect of working with mobile development, particularly for Android, not so much for iOS, is to use a development tool that enables rapid development and rapid iteration. And I've found that Android Studio is a great IDE and continually being improved and has really great integration with the Google Cloud. So I would heartily recommend that if you're doing this type of solution, you investigate Android Studio for development if you haven't done so already. The next architecture we're going to examine is one that I've been working with more and more with newer clients, particularly this year. And this is Internet of Things or real-time stream processing. So you can see in this architecture, we have a number of devices producing information, and the results from those devices needs to be queryable and visualizable. So Google recommends using a load balancer and then one or many instances of App Engine on the front end, which of course will auto-scale, an architecture that should be quite familiar with by now, coupled with Compute Engine. In this case, they're using RabbitMQ, which is message queuing, to queue up information of interest, and then a secondary set of Compute Engine instances, which they call a storm cluster, which then takes the information from the first set and then does further processing on it in preparation to pass it to multiple data stores. Now, this is really an interesting architecture and one that I find particularly useful for this type of information. So to put some context to it, think of these devices as consumer electronics, smart electronics, so thermostats, refrigerators, toasters, so on and so forth. And they are producing events of different types. So their event information is coming through the system, and then once it hits the storm cluster, then the information is either queried by BigQuery and then passed to the visualization tool, which could be a custom tool or something implemented from a partner like Tableau or ClickView or BIME, as we saw in an earlier movie. Or it could be stored as raw data, again, cheaply in cloud storage, and then perhaps subsequently aggregated and processed using Cloud SQL, and then further processing applied using App Engine. Now, they specify here modeling and analytics, and what that generally will be is some kind of machine learning or data mining. And that could be a commercial project, or that could be something that is proprietary to the particular solution provider. In my case, it was knowledge about, for example, which models of refrigerators would have which kind of problems based on the events coming in, which type of washing machines would need which type of maintenance. And then it could result also, they don't show this here, in notifications using mobile architecture on the cloud back to the client, in other words, the user of the device, that can then say, it appears based on the pattern that your device or your washing machine in this case should be having regular maintenance. Go ahead and schedule that. And keeping the customer happy, keeping the customer using that particular platform. So this type of architecture is one that I'm using very, very commonly. The one thing that I would add that's not shown is possible use of Bigtable. Bigtable could be used somewhere over here, depending on the raw volume of information, because Cloud SQL, of course, has the hard limit of 250 gigabytes per instance, which you can request to be increased as of this recording to 500 gigabytes. But that easily can be not sufficient for these kind of scenarios. So you may want to put a layer in between the raw storage here and the Cloud SQL, which is the aggregate information, which is Bigtable, which could be queried by, for example, in the case of the architecture I designed, the service person to see what the event streams were, because the service person wanted to see exactly event A, event B, event C, whereas the analyst wanted to see the count of the events, so the aggregate information, and that would be stored in the Cloud SQL section of this. So the common architecture that we see across all of the three reference architectures I've talked about here are multiple uses of App Engine and or Compute Engine in conjunction with this partitioning of data across data stores. So one of the big takeaways here is when you are setting up your minimum viable products and your proof of concept is to try to go beyond the more non-cloud traditional infrastructure of a front end, and then a relational back end, because that really is an outdated architecture in the world of choices and cloud solutions. Now that we've looked at architectures and learned about services, it's time to summarize and think about best practices. So one of the most important best practices that I would advocate is to start small. And I have a focus on storage, which might be because of my relational database and data warehousing background. But I find because of the new architectures and the new services that I've talked so much about in this course, it takes some careful consideration to select and use properly the appropriate mix of storage services. And you'll remember that that's both file and database services. And there are so many choices to pick from, why I had such a focus on that in this course. And I recommend you always start with the core Google Cloud storage, the file storage, and then you layer on the various data services and you test and try and see what works best for not only your business implementation, but what is the most usable by the team that you have. And questions around that are, do you understand only how to do relational queries? Do you have Hadoop knowledge on your team? Do you have experience with NoSQL databases, and so on and so forth? Of course, compute is a key option of any set of cloud services, and the options around compute are growing ever more complex because of the balance between fully managed and non-managed, and now partially managed, with the implementation of containers, Docker, and Kubernetes. That is in addition to Google Compute Engine VMs and Google App Engine fully managed services. So this is a mix that you have to, again, determine by starting with small projects and seeing what works best for your teams and for your skills. Of course, layering on top of that, you're going to need some of the other services, whether it's authentication and security, whether it's management and monitoring, whether it's caching, whether it's network services. And what I find is those services are often not discovered because people are focusing so much on storage and compute. That's why I tried to cover them as completely in this course as the other core set of services, because they are important. It's very, very important in terms of IP addresses and routing and load balancing and so on and so forth. Those services are sometimes required, and at other times they can really optimize your particular situation. Don't forget about testing and monitoring. What I see often in the rush to getting solutions out to the cloud is there's inadequate testing, particularly around my favorite subject, data. One of the areas that I'm insistent on in the proof of concept phases and the minimum viable phases is data testing across the various systems. One of the complexities that comes up with these different data systems is that they have support for different data types. So sometimes something as basic as losing precision by moving data from data system A to data system B results in queries that are inconsistent. So you can't lose the basics even when working with these modern systems. Monitoring is another aspect. Even if you're working with a partially or fully managed app engine or containers, you still have to have some aspect of monitoring, not only for performance, but more and more for cost, so that you're not surprised by cost. And this is particularly the case with Google Cloud Services since they're set to auto scale. So you don't want to be surprised by unexpected costs. And of course, you can't forget about disaster recovery. One of the more modern aspects of cloud solutions that I'm starting to work with is multiple implementations across different locations. So in the case of the Google Cloud, that might be US and Europe for redundancy. Another situation I'm seeing is working across vendor clouds. So having a core implementation on Google, but maybe having a secondary implementation on Rackspace or Azure or Amazon, just to ensure service continuity. So this is a whole new set of complexities, but if your business is wholly dependent on a single cloud region or zone or area, it is imperative that you not only have a disaster recovery plan, but you also test it. Very, very important. And of course, these core components, along with these best practices, is a basis for having a successful set of cloud-based projects. So what are some of the considerations that I recommend based on my experience? First, if you are going to do some pattern that is outside of the guideline recommended by Google, have a compelling business reason to do so. Again, I see that services are used in non-traditional ways, and then unexpected service results occur. The most common situation I see is when data services are not correctly understood, and in particular, transactional behavior is manually created. If you need transactional consistency, the best bet is to use a relational database. And if you need to partition it, then partition it. I see all kinds of bad situations when there is a lack of understanding of the capabilities of the data structures. I also see frustration around App Engine in thinking that it's a direct port from more traditional web applications, because it isn't. It's partially managed, and there will be some restrictions on the APIs that you use because Google is restricting, for example, things like access to the file system directly on the App Engine instances for security purposes. So read your documentation and follow the guidelines. And if you're going to vary from service guidelines, have a very good business reason and document it so that other people who work on your system can understand why you did that. You're going to want to load test not only so you have service reliability, but you want to load test to forecast costs. This is particularly important with Google Cloud because of the auto scaling. I've said this several times through this course, but I've had almost every customer I've worked with get, quote unquote, surprised by costs when they had not a bad business problem. They had more business than they anticipated. So what you want to do is work with your Google teams if you are a huge volume enterprise and they're anxious to have you bring your solution onto their cloud. So you want to connect with them and have them help you to forecast the costs so that you don't have any surprises. So this is literally a section from Google's launch checklist. So Google recommends the following when you are deploying your cloud-based solution to production to establish your points of contact with Google. And I really recommend that you follow this checklist because Google's support is different than some of the other commercial providers out there, and you want to make sure that you're getting the level of support that you need for your particular application. So you can see you want to purchase support at least silver level, and they have different levels of support. So you want to click on these links to understand what's going to be appropriate for you. And then you want to just go through these other options on this checklist. In particular, you want to notify Google of the launch using the template so they are aware that you're in production. They're really there to work with you in terms of understanding costs and best use of services, but you need to follow their processes so that they can work in partnership with you to have a successful implementation of your cloud project. As you work with the Google Cloud, be sure to understand and use resources available to you. And these fall into two sets. Google itself has sets of resources that I think are key to successfully using the cloud. And these are developer guides, code samples, and people. That's their developer relations team. They have developer relations people that are associated with each of the core services. So, for example, BigQuery and Bigtable and so on and so forth. And then they have developer relations people who are associated to regions. So North America, West Coast, Europe, so on and so forth. Get to know both. They can really, really help you out. In addition to resources from Google, there's a community around Google Cloud. So there's a set of recognized external experts called Google Developer Experts for Cloud that I highlighted in an earlier movie. You'll want to locate and follow your favorite GDEs. They blog, have sample code, do presentations, and are generally great resources for understanding more about Google Cloud services. Searching Stack Overflow is another way to find common answers to common questions about Google Cloud services. For example, I follow the BigQuery section on Stack Overflow, and I've learned a lot from doing so. And finally, searching on GitHub for sample code is a great resource that I've used many, many times. To summarize, using your resources is an important aspect of having success using Google Cloud services.